Hey, this is Jason Molesky. In this example, we'll take a look at comparing two population means. Does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. The relationship was strongest for black men. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy black men who volunteered to take part in the experiment. They were randomly assigned to two groups. 10 of the men received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. The experiment was double-blind. The response variable is the decrease in systolic, the top number, blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. Here are the data. So for group 1, the calcium group, we can see decreases of 7 millimeters of mercury, increase of 4, decreases of 18, 17, and so on, and similar data for group 2, our placebo group. Now for this problem, we want to know if the data provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo. We'll need to carry out an appropriate test to support our answer. Then we'll have to interpret the p-value in the context of this experiment. So let's follow our familiar four-step process, starting by stating our problem. We want to perform a test of the null hypothesis mu sub 1 minus mu sub 2 equals 0 against the alternative mu sub 1 minus mu sub 2 is greater than 0, or equivalently, we want to test the hypotheses where the means are equal against the alternative mu 1 greater than mu 2. Where mu 1 is the true mean decrease in systolic blood pressure for healthy black men like the ones in this study who take a calcium supplement, and mu 2 is the true mean decrease in systolic blood pressure for healthy black men like the ones in this study who take a placebo. No significance level is specified, so we'll go ahead and use alpha equals 0.05. Well, we need to check our conditions. If they're met, we'll carry out a two-sample t-test for the difference of means. The 21 subjects in this case were randomly assigned to the two treatments, so our random condition is met. For a normal large sample, we note that with such small sample sizes, we need to graph the data to see if it's reasonable to believe that the actual distributions of differences in the blood pressure when taking calcium or placebo are normal. Well, when we look at these comparative box plots, we can see that we don't have any evidence in our experimental group, the calcium group, of strong skewness or any outliers. And likewise in our placebo group, when we plot that sample data, we don't see strong skewness or any outliers. The graphs don't show those, so we're safe using two-sample t procedures. Now from the data, we calculate some summary statistics. For our calcium group, our sample size was 10. The mean decrease was 5 millimeters, with a standard deviation of 8.7 millimeters. And for our placebo group, our sample size was 11. We actually had a mean increase, or in other words, a mean decrease of negative 0.273 millimeters, and a standard deviation of about 5.9 millimeters. To calculate our test statistic, we use our t formula, and we get a test statistic in this case of 1.604. Now, by the conservative method, using the smaller of our two sample sizes, we'll use 9 degrees of freedom. Because the alternative counts only positive values of t as evidence against the null, the p-value is the area to the right of our test statistic 1.604 within that t distribution with 9 degrees of freedom. Now if we look that up in table B, we can find that the p-value lies somewhere between 0.05 and 0.10. If we were to use technology, using a two-sample t-test, we get t equals 1.60, and we get a p-value of 0.0644, using the actual degrees of freedom, in this case, 15.59. Now, if you're going to use technology to do the problem, you want to make sure you indicate the test statistic, the p-value, and the degrees of freedom when you give all of your evidence for the test. Now, because our p-value here is greater than our 5% significance level, we fail to reject the null hypothesis. The experiment does not provide convincing evidence that the true mean decrease in systolic blood pressure is higher for men like those who take calcium than for men like those who take a placebo. Now, assuming that the null were true, there's a 0.0644 probability of getting a difference in mean blood pressure reduction for the two groups of 5.273 or greater just by the chance involved in the random assignment. Now, for some additional practice in performing a two-sample t-test for the difference of means, Or for some additional practice in interpreting a p-value, try exercise 41.